Hello friends, as I told you in last video that in upcoming videos we are going to apply the backpropagation algorithm. So today we are going to apply the backpropagation algorithm on a particular neural network. Okay, but before that let's have a quick look on backpropagation algorithm. Okay, now we are having input layer, then we are having hidden layers. So input layer will have some weights assigned to it, then input and weight will be multiplied. You will have the weighted sum, then that weighted sum and the bias will be transformed to the output, and at the output layer, you will find out the difference in between the desired value and the predicted output, and based on that, you will back propagate. Now remember, while back propagating, you have to start from output layer, then from last hidden layer to its previous hidden layer, and like this you will come back to the input layer. So the backpropagation is based on the error. So that error first you have to calculate at the output layer, then in the hidden layer previous to that output layer, and like this you have to propagate to the input layer. And while backpropagating, what you are updating the weights and the bias, and there are different formula for the weight updation and bias updation that we have seen. So now let us see one example based on this backpropagation. Now, this is my network. So in this network, in input layer, I am having three nodes, that is X1, X2, and X3. Then there is only one hidden layer, I'm assuming, for simplicity. So this is a very simple example on which you will apply backpropagation. So in more and more practice, you can go for the complicated examples. Then in hidden layer, how many neurons I am having? Only two neurons, that is 4 and 5. And finally, I will get a one neuron in the output layer. Now for easy remembering purpose, the weights are assigned from your input to the, it means whatever is the numbering given to your nodes, in the same way the weights are numbered. So the initial values of your inputs, weights and bias are given to you in this table. Okay, that you can see very clearly. Now, what will be our first step? Input should be multiplied with your weight. Okay, so x1 multiplied with w1 4. So 1 is multiplied with 0.2. What you will get? 0.2. Okay, then x2 is 0. So whatever is that multiplication, that will give me 0 only. Now x3 and w34. So what is your x3? 1. And what is your w34? 0.5. So which values you will consider? The 0.2 and 0.5. Okay, so here you will consider which value is 0.2, the x2 was 0, that's 0, and 0.5. Now, what is minus 0.4? That is a bias at the node 4. So that you can see as a 0.4. So when you sum all this, what you will get? Minus 0.7. What you will get? Minus 0.7. Now, this is the weighted sum plus bias. Now, is this your output? No. This value should be transformed to output using the activation function. Now, as I told you, the activation function that you are using is a sigmoid activation function. So that 0.7 will become the power of your E. Now, actually, what is the formula? 1 divided by 1 plus e raised to minus x. But already your x is minus. So that's why it will become the plus 0.7. Now, what is the output you are getting? 0.332. So this is the output you are getting at the first node of your hidden layer, that is the node 4. Okay. Now, in the same way, repeat the same procedure. You will get the output at the node 5. And finally, you will get using these two outputs as input. Okay. Using these two outputs as input and the corresponding weights and the bias, you will get the output at the last level, that is your output layer. Okay. Now, what I have to do? After getting this predicted output, I have to propagate in the backward direction. Now, while that propagation is going on, I need the updation in my weight and updation in my bias. Now for updating weight, I have to find out the derivative of error. Now for finding out the derivative of error, first I should calculate the error. Now, as I told you, the error will be calculated using different formula at this output layer and using different formula at this hidden layer. Okay. Now, what is the formula to calculate your error at the output layer? O, 1 minus O, T minus O. Now, what is your O here? 0.474. Okay, so that is given here. Now, 1 minus O will be this term. Okay, now T, that is the expected output, I'm considering as a 1. So, this will be the T minus O. Now, what is the error at the output layer? This one. Okay. Now, that error will be used for propagating in backward direction to the hidden layer. Okay, so this error only I am using here by multiplying with the weight. So this 0.131 should be multiplied with the weight at the node 4. That is a 0.2. Okay, and again O and 1 minus O at that particular point will be taken from here. Okay, now that multiplication will be here, and finally you will get the error at the hidden layers. Okay, hidden layer 5 and 4 at those nodes of the hidden layer. Okay, now using these values, how you will calculate the delta? To calculate the delta means how you will update the weight. You have to multiply the learning rate with that error and the output, and then that will be added to your old weight to get the new weight. Now, what is your old weight? W46 is a 0.3. Okay. Now to 8, what should be added? Delta. But how you are getting the delta? Learning rate, error, and the O. Now here learning rate I'm considering as a 0.9. Now the error at node 4 is what? Point here, what it is? 1311. Okay. So here it is given. And 0.33 was the output at that layer. So this is the updation in the node, updation in the weight 46. So in the same way, you have to calculate the updation in weights in reverse direction by using these two formulas only. I'm not using these two formulas separately. With the old weight, directly I'm adding this value. That's why you will get it in one step only. Now for updating theta, just you have to consider the learning rate and error. You are not considering the O. So for updating the theta 6, what you can see here is the old value of your theta, that is the 0.1, and you will get this term. Only this term we can see here adding. So you will get the new theta at the node 6. So in the same way, you will calculate the remaining 2 thetas also, that is your bias. So with these all new values of the weight and bias, again you have to continue the forward pass. So means again you have to go from your input layer to output layer. So one epoch will be completed. Again, by using the backpropagation, the convergence in the weight and bias will be done. So this is what the backpropagation algorithm. So in exam, they may give you the input, weight, and bias, learning rate, and expected output. So like this only you have to calculate the new weight and new bias, and you can say that the forward pass will be continued. So this is what your application of the backpropagation algorithm. So input X will be there. The weights will be given. Okay. And then you will proceed from input layer to hidden layer to the output layer. Then you have to calculate the error. What is your error? Actual minus desired, and travel back to adjust the weight in such a way that the error is decreased, and keep repeating this process unless and until desired output is arrived. How you can find out whether desired output is arrived or not? When this difference is very minimum, that is the global minimum. So that is what the gradient descent algorithm. So your whole backpropagation is based on the gradient descent only. Okay. So I would like to give you one example which you can solve as an assignment. Now you can see here the same network that we have seen just now. The instead of 3 input, we are having only 2 inputs here, then 2 hidden layer and 1 output layer. Then the inputs are given to you, weights are given to you. And here what I am saying, what is my actual output? 0.5. in the explained example, it was 1. Learning rate I have taken as 0.9, but here it is 1. So yeah, using the sigmoid activation function, just like I have explained the sigmoid activation function, perform the forward pass, perform the backward pass. Means you have to apply the backpropagation algorithm so that you can perform the next forward pass. So try to solve this example and remember that during face-to-face interview for any company that is based on machine learning, they will give you any such type of the network and they will ask you to apply the backpropagation algorithm. So backpropagation algorithm is very important from your career point of view. So practice more and more examples on it. At least you practice the 2 examples that are given in this video so that you can become very perfect. And in exam also, in same exam also, they will give you any network and they will ask you to apply the backpropagation algorithm on it. Okay. So the practice will only help you to remove the fear on the backpropagation algorithm. There are more and more calculations, but in these all calculations, the 2 formulas that you have to remember is one, how to calculate the error, and another one, how to update your weight and bias. So these are the 2 important formulas that you have to remember. Then only you can solve any example given to you on such type of the network. Okay. Thank you, all of you. Thank you very much. So this is the end of your unit 1. So what we have learned till now in unit 1, what do you mean by neuron, perceptron? What do you mean by neural network? What are the types of the neural network? What do you mean by activation function? What are the type of the activation function? Then MLP, that is a multi-layer perceptron network. Then the backpropagation algorithm and applying that backpropagation algorithm on one example network. So this is all about your unit 1. Thank you.